Good evening, viewer. Welcome to our Globe TV. Here's breaking news and most amazing too. More than 100 million years ago, the ancestors of the first snakes were small lizards that lived alongside other small, nondescript lizards in the shadow of the dinosaurs. And in a burst of innovation in form and function, the ancestors of snakes evolved legless bodies that could slither across the ground. Highly sophisticated chemical detection systems to find and track prey, and flexible skulls that enabled them to swallow large animals. Those changes set the stage for the spectacular diversification of snakes over the past 66 million years, allowing them to quickly exploit new opportunities that emerge after an asteroid impact wiped out roughly three-quarters of the planet's plant and animal species. But what triggered the evolutionary explosion of snake diversity? A phenomenon known as adaptive radiation that led to nearly 4,000 living species and made snakes one of evolution's biggest success stories. A large new genetic and dietary study of snakes from an international team led by University of Michigan biologists suggests that speed is the answer. Snakes evolved up to 3 times faster than lizards, with massive shifts in traits associated with feeding, locomotion, and sensory processing, according to a study recently published in the journal Science. Fundamentally, this study is about what makes an evolutionary winner. We found that snakes have been evolving faster than lizards in some important ways, and this speed of evolution has let them take advantage of new opportunities that other lizards could not, said University of Michigan evolutionary biologist Daniel Roboski, senior author of the science paper. Snakes evolved faster, and dare we say it, better than some other groups. They are versatile and flexible and able to specialize on prey that other groups cannot use, said Roboski, a curator at the Museum of Zoology and a professor in the Department of Ecology and Evolutionary Biology. The study, researchers generated the largest, most comprehensive evolutionary tree of snakes and lizards by sequencing partial genomes for nearly 1,000 species. In addition, they compiled a huge dataset on lizard and snake diets, examining records of stomach contents from tens of thousands of preserved museum specimens. Fed mountain of data into sophisticated mathematical and statistical models backed by massive amounts of computer power to analyze the history of snake and lizard evolution through geological time and to study how various traits such as limblessness evolved. The multi-pronged approach revealed that while other reptiles have evolved many snake-like traits, 25 different groups of lizards also lost their limbs. For instance, only snakes experienced this level of explosive diversification. Take Australia's legless gecko for example. Like snakes, this lizard lost its legs and evolved a flexible skull, yet the creature has barely diversified over millions of years. No evolutionary explosions, just a couple of species scrapping out a living in the Australian outbreak. So it seems there is something special about snakes that enabled them to hit the evolutionary jackpot. Maybe something in their genes that allowed them to be evolutionarily flexible while other groups of organisms are much more constrained. Bien, that's it. Globe TV, Delhi, Bharat.